In this video, we're going to be learning how to graph a quadratic equation in standard form. So previously we talked about some of the key terminology for quadratic equations, so let's refresh our memory on some of those. So if you recall, we talked about the axis of symmetry before. The axis of symmetry is a vertical line, that passes through the vertex. If you recall, the vertex was either the minimum or maximum value for your function, so it was like the highest or lowest point on your graph. And we call the graph of a quadratic function a parabola, and a parabola is symmetric about the axis of symmetry. So that's why it's called the axis of symmetry. So if you were to fold your parabola along the axis of symmetry, the right side should land exactly on top of the left side. Okay, so if you were given a graph like this, how would we identify the axis of symmetry and the vertex? So if you recall, they said the axis of symmetry goes through the vertex. So if the vertex is our highest or lowest point, so in this case it's our maximum, our axis of symmetry is going to be this vertical line here. Now remember, vertical lines always have an equation of x equals some number. So it's just going to be whatever the x value is that it's passing through. So it's x equals 2. And then the vertical line, right, the equation of the vertical line, that gives us the x-coordinate of our vertex, and then the y-coordinate would just be whatever the y-coordinate is. So this one is at 2, 0. So our vertex is at 2, 0. Now in this one, we're not given the point where the vertex is. I have a good idea that it's probably here, but we're given two solutions, two x-intercepts. So when you're given your x-intercepts, or you're given 2 points on your graph, the axis of symmetry is actually always going to be halfway in between, right in the middle of your two intercepts. So we can see that these two are 4 units apart. So if I go 2 units to the left or to the right of my my x-intercepts, I will get my axis of symmetry. So this vertical line right here at x equals 3 is going to be my axis of symmetry. So the x-coordinate for your vertex comes from your axis of symmetry, and then it's down here is going to be my y-coordinate. And so this is a minimum, and my minimum value is down here at -8. So 3, -8 is my vertex. Now this is how you would find the axis of symmetry and vertex graphically. But what if we were trying to find it algebraically? What if we were just given the equation of our graph? Or sorry, the equation for our graph. So if we're given a quadratic function in standard form, y equals ax squared plus bx plus c, the axis of symmetry is found with the equation for this vertical line, x equals the opposite of b divided by 2a. So you take the value of b here, take its opposite, and then divide by twice the value of a. And that's going to give you the equation for that vertical line that is your axis of symmetry. Now this negative here really could go either on top or bottom, but generally we put it up here with the b. We just take the opposite value of b, and it kind of makes things a little easier when trying to do this. So let's go ahead and try a couple of these. So we want to find the equation for the axis of symmetry for these two functions. So remember, this is just function notation. It really just means y, right? It just means y. So that shouldn't really throw us off too much. So if we want to find the equation for the axis of symmetry, so it's always x equals, because it's a vertical line. So we take the opposite of b, so -b, divided by 2 times a. So b in this case is -5, so the opposite of -5 is going to be +5 over 2 times a, which is 2, right? So a here is 2. So the opposite of -5, that's +5, so that's going to be 5, and then 2 times 2 is 4. You would reduce your fraction if possible, but in this case it can't be reduced, so x is 5/4 is our axis of symmetry. So let's try this one here. So it's going to be x equals the opposite of b, so b is +4, so we're going to take the opposite of b, divided by 2 times a, which was 1. Remember, if there's not a number written there, there's an implied 1 there. So that's -4 divided by 2, which is 2. So x equals 2 would be our axis of symmetry for that equation. Now, why do we care about the axis of symmetry? Well, first, the axis of symmetry helps us find the vertex for our function, which is generally where we're going to start by graphing. And it's also the vertical line by which our function is symmetric about, so we can actually use some of those properties to help us graph. So another thing that we need to know how to do, so we looked at how to find the axis of symmetry algebraically, but if we're not given the graph, we need to be able to find the vertex. So how do we do that? So if I want to find the vertex algebraically, the first thing we're going to do is find the axis of symmetry. Because remember, the axis of symmetry is going to give us the x value of our vertex. So the x value of the vertex is found by finding the axis of symmetry. So once we find the axis of symmetry, we then substitute this x value from the axis of symmetry into the equation, and that will give us the y value. So you plug it back into your equation, that's going to give you your y value. So now that you have the x coordinate, right, the x coordinate comes from the axis of symmetry. Find the y coordinate by plugging it back in. You just then write your 2 points, your two values in the ordered pair x, comma, y. And that'll give us our vertex. Okay, so let's go ahead and try some of those. So we want to find the vertex for this function. So the first thing that we want to do is find the axis of symmetry. So it was x equals the opposite of b. So b in this case is negative 10. So it's the opposite of negative 10. Divided by 2 times a. A is 5. So the opposite of negative 10, that's positive 10. Divided by 2 times 5. So 2 times 5 is 10. So that's 1. So x equals 1 is the equation for the axis of symmetry. So remember, this f of x really is just function notation. It really just means y. So we're trying to find the y coordinate by plugging in 1. So what is our function evaluated at 1? So this just means f of 1. You're plugging 1 in for x. So 5 times 1 squared minus 10 times 1 plus 3. 1 squared is 1 times 5, that's 5. 10 times 1, or negative 10 times 1 is negative 10. And then plus 3. 5 minus 10 is negative 5. Negative 5 plus 3, that's negative 2. Remember, this is the y coordinate. This is the y coordinate. So the third step would be to write your ordered pair as 1 comma negative 2. So this would be our vertex. That's the vertex. Okay? So how do we use this, all of this, to help us graph? So if we're trying to graph a quadratic, there's a couple things we need to do first. So the first thing that we want to do is determine whether our graph opens up or down. So if you recall, our graph opens up when the a value is positive, and it opens down when a is negative. So if you have a negative a value, right, a value less than 0, then that tells us our graph opens down. If a is positive, then that tells us our graph opens up. And the reason why we care about this, it just kind of gives us a sense of, are our points going in the correct direction, right? And it gives us kind of a general idea of what our shape should look like. So opening up would look like this, right? Opening down would look something like this. And we talked about this again in that other video where we introduced quadratic equations. So once you've determined whether it opens up or down, we want to find the axis of symmetry. Remember, we use this, x equals negative b over 2a. And then the vertex, this is just the x coordinate from the axis of symmetry. And then that is just plugging it back into our function. And then once we've done that, we're going to use symmetry about our axis of symmetry to help us find other points. So we're going to pick points close to our vertex and then use the axis of symmetry and symmetry to help us complete our graph. Okay, so let's go ahead and try a couple of these. So we want to find the graph of this function in standard form. So first, does this open up or down? So a is negative 3, so it's negative. So this opens down. So we should have a graph that kind of goes down like this. So that's the first step. The second step is to find the axis of symmetry and vertex. So x equals the opposite of b. So b is 6. So the opposite of b over 2 times a, which is this. So that's x equals negative 6 over negative 6, which is positive 1. So that's the x coordinate. So positive 1. And then let's find the y coordinate by plugging it into this. So it's negative 3 times 1 squared plus 6 times 1 plus 5. 1 squared is 1 times negative 3. That's negative 3. 6 times 1 is 6. And 5. So that's going to be 3 plus 5 is 8. So we have the vertex at, so the vertex is at 1, 8. So 1, 8 is our vertex. I'm actually just going to sketch in my axis of symmetry. I'm going to use a vertical line here like this to sketch in my axis of symmetry. Let me put my vertex back here. Okay, so here's my vertex at 1, 8, and my axis of symmetry is there in blue. So now I need to pick some other points to graph. Now what I'm going to do is I'm going to go, you can either go like 2 points to the right or 2 values to the left and then use symmetry. I'm going to go left just because it's going to give me some nicer numbers, right? If I could plug in 0 ever, it's kind of nice to do that. Now I could plug in things like -5 and 5, but generally you want to try and stay pretty close to your axis of symmetry because quadratics grow pretty quickly. And so if you pick numbers that are too big over here, they might be off of our graph. So let's plug in 0 and then -1, and we'll use symmetry. So if I plug 0 in, -3 times 0 squared, plus 6 times 0, plus 5. 0 squared is 0, times -3 is 0, 6 times 0 is 0, and then plus 5, so that's going to be 5. So 0, 5 is our first other point that we're going to use. Now, if you recognize this point here is 1 unit away, it's 1 unit to the left of our axis of symmetry. So because of symmetry, right, that means if I go 1 unit to the right of my axis of symmetry, I should also get this value. Now you can always check that by plugging 2 into your equation, and you'll see that you should get the same y value. Okay, so let's try -1. So 3 times -1 squared plus 6 times -1 plus 5. -1 squared, -1 times -1 is +1, times -3 is -3. 6 times -1 is -6, plus 5. So that's -9. -9 plus 5 is -4. So we have -1, -4 here. You can see that this is 2 units to the left of the axis of symmetry. So if I go 2 units to the right, I should also have a y value of -4. And then you just sketch in your curve like this, and you should be good to go. And that would be how you graph a quadratic function. This isn't a very good graph of mine, but you get the point. So let's look at another example. Okay, so we want to graph this function, y equals 2x squared plus 8x. So first, we want to know, does it open up or down? So this opens up because a is positive, right? A is +2, so it opens up. Second thing we want to do is find the axis of symmetry. So x equals. Now in this situation, there's no value of c, but that doesn't impact our axis of symmetry, right? It doesn't impact the axis of symmetry. So it's the opposite of b, so it's the opposite of 8, over 2 times a, which is 2. So that's x equals -8 over 4, which is -2. So -2 is going to be our axis of symmetry here. So I'll draw that again in blue here at x equals -2. And then plug it back in to get your y coordinate. So what is 2 times -2 squared plus 8 times -2? -2 squared, so -2 times -2 is 4. 4 times 2 is 8. 8 times -2 is -16. 8 minus 16 is -8. So our vertex is at -2, -8. So -2, -8, that's down here. So there's our vertex. Now again, I want to pick either 2 points to the left or 2 points to the right. I'm going to go to the right this time because I can get -1 and 0, which I think will be easier than -3 and -4. So -1 and 0. I'm going to use those values. So let's plug -1 in. 2 times -1 squared plus 8 times -1. -1 times -1 is 1, times 2 is 2. 8 times -1 is -8. So 2 minus 8, that's -6. So -1, -6. Now again, symmetry tells me I am 1 unit, this time to the right of my axis of symmetry. So if I go 1 unit to the left, I should get another point on my quadratic. So where you can see that symmetry there. So plug in 0. 2 times 0 squared plus 8 times 0. 0 squared is 0, times 2 is 0. And then 8 times 0 is 0. So I end up with 0, 0. So 0, 0. The origin is part of our graph. So if I go 2 to the right, that gives me that point. So go 2 to the left. There at a y value of 0, I should get that point. And then again, sketch in your curve, something like this. And there you are. And that would be how you graph a quadratic in standard form.